Hello, Algebra 2 students. This is Mr. Weber. How you doing today? I hope that you're doing well. Today we're going to talk about a review of kind of trigonometry, Pythagorean theorem, some things from geometry that one you should already know, but two are going to be super important because we're going to apply them to our new context in this unit. So we just want to go back and make sure that you understand all this geometry content. Hopefully this is a good review and it's not too difficult. But if it is, reach out to your teacher as always. They'll be more than willing to help you out. Okay, you will need a calculator for this lesson. So if you don't have one with you, you can go ahead and grab an online calculator. It should be scientific. All right, let's go. Okay, so Pythagorean theorem. Who remembers what that was? I know, you've heard it before, but what's the formula? If you don't remember, I understand. It's a really difficult formula to remember. It's a squared plus b squared equals c squared. But what is a, b, and c? A and b are the legs. C is the hypotenuse of a right triangle. So we have a right triangle with a right angle. Remember, the legs are the sides that form the right angle. The hypotenuse is the side that is opposite the right angle. Okay, so here's our right angle. C is opposite that right angle. That's the hypotenuse. A and B would be legs. Okay? All right, so here we go. Use Pythagorean theorem to find the missing side of each triangle. Leave your answers in simplest radical form when necessary. No decimal values. Okay? All right, so here we go. First thing we do is we take Pythagorean theorem. A squared plus b squared equals c squared. We got to figure out what is a, what is b, what is c. Remember, a and b are the legs, so this could be a and this could be b. But here's my right angle, so 15 has to equal c. Okay, so if we plug those in, we get 12 squared plus b squared equals 15 squared. Could you have said that a was x and b was 12? Absolutely. Doesn't matter which leg you say a is a, which one you say is b, as long as you have 12 on the left side and 15 on the right side, then you're doing great. All right, so now we simplify. What's the next step? We've got to deal with those squares. 12 squared is 144. 15 squared is 225. Here's where the calculator is going to come in handy. And now what? Well, we're trying to get the b squared, so the next move is going to be to get b squared by itself. So we're going to have to subtract 144 from both sides of the equation. So now we'll have b squared on the left, and on the right we're going to have 81. All right, that's not our answer. B is what we're looking for, not b squared. B squared is 81, so how do we get to b? Take the square root of 81. So the square root of 81 is 9. Quick question, could it be negative 9? Isn't it, anytime we take the square root, isn't it plus or minus? Technically, yes, but because we're talking about a triangle, distance can never be negative, so we're only going to take the positive value. It's going to be easy on you. You don't have to worry about that plus and minus in this particular lesson. Okay, are we good? X equals 9. And we're done. That's all we got to do is find the missing Pythagorean theorem. All right, here we go. 2. Same thing. We got to figure out what is A, what is B, what is C. All right, I always find the hypotenuse first, so there's my right angle. I go straight across, so there's C. 14 has to be C. That means these other two sides that form the right angle have to be A and B. And again, it doesn't matter which way I label those or I order those. Let's go ahead and see how this works out. All right, so we get our Pythagorean theorem. That's where we start. A squared plus b squared equals c squared. Plug in what we know. We know A is 6, and we know C is 14. Okay, so 6 squared plus b squared equals 14 squared. All right, next move is going to be to simplify this. So we'll have to deal with those squares. 6 squared, that's 36. 14 squared, here's where the calculator comes in handy, 196. So we get 36 plus b squared equals 196. 36 plus b squared equals 196. All right, now we're going to try to get b squared by itself. So we subtract 36 from both sides. B squared equals 160. Okay, remember that's not b, that's b squared. So what do we have to do? We have to take the square root of 160. And so here's the part that's a little bit different. Is we look at our directions, it says we got to answer this question and leave it in simple radical form. Simplest radical form. That means no decimal values. So if you put the square root of 160 and you got a crazy decimal, that's your clue. Wait a minute, maybe I could simplify this a little bit more. So there's a couple ways you can do this. One way is to think about what are your perfect squares. All right, so think about what is 1 squared. 1 squared is 1, obviously. We're not going to deal with that one. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. So you can keep doing this if you would like. This is one way to tackle this. Is what we're doing is we're basically looking for these perfect squares to be factors inside of our radical. So when we see the square root of 160, we're going to ask ourselves, is there one of these values that is a factor of 160? And we can say, yes, there is. 16 is a factor. 16 times 10 is 160. So we can break up 160 into the square root of 16 times the square root of 10. All right, so remember when you have those two radicals, you just multiply what's underneath. So 16 times 10 is 160. Hopefully that's okay and you're with us. The square root of 16 is 4. So our answer is 4 times the square root of 10. Okay, now let's say that you're not good at remembering what all the perfect squares are. You need a different method. All right, so here's another method. Another way of getting to the exact same answer is called prime factorization. You take the number that's underneath the radical, in this case it's 160, and you think to yourself, what are two numbers that multiply to give me 160? Any two numbers. All right, let's make this simple. Maybe I say 2 and 80. I could have easily chosen 16 and 10. I could have chosen 4 and 40. But let's say I can't think about it. I don't know all of these big numbers. Remember, if it's an even number, you can always take 2 out of it, right? So about 80. All right, so 80, we can take that out and say, well, that's 2 times 40. And what about 40? Whoops. Woo. 40, I know, is going to be 8 times 5. And then here we have 8 is 2 times 4. And then 4 is 2 times 2. So all we're doing is we're breaking these down. If there's a number that can be broken up into two smaller factors, then we're going to do that. And so what we end up with is that this number 160 is going to equal 2 times 2 times 2 times 2 times 2 times 5. All those numbers multiplied together, that's 160. All right, so because we're looking for square roots, what we're looking for is we're looking for pairs of numbers. Do we have any two numbers that are the same? And if we do, what we can do is move that number from the inside to the outside. All right, so here we go. I have a pair of 2's here. That means I can write a 2 on the outside of this factor. I have a pair of 2's here. That means I can write a second 2 on the outside of the factor. Now, if we look here, this 2 and this 5, they don't have a match. They don't have a match. They're all by themselves. When that happens, those numbers have to stay on the inside of the radical. So I'm going to have a 2 inside and I have a 5 outside. Okay, so sometimes I think about it like it costs 2, like that radical is kind of like you're in jail, and it takes 2 factors that are the same to get that number out. All right, so I have 2 2's, so I get 1 2 on the outside. I have a second pair of 2's, so I get a second 2 on the outside. And then a 2 and a 5 is left over, so it has to stay on the inside. Whenever you have more than one number left over, either on the outside or on the inside, we simply just multiply those things together. Losing my mouse. There we go. So we'll multiply this, and we end up with 2 times 2 is 4, 2 times 5 is 10, and guess what? That's the exact same number that we got over here. Okay, so the answer needs to be simplified into its most simple radical form. If you have a calculator, some calculators will do that radical simplifying for you. But if not, do your prime factorization or just look for those perfect squares that are factors and simplify it on your own. Okay? All right, here we go. Next, we could do Pythagorean theorem all day. It works for every single right triangle. However, there are certain right triangles that have certain angles where there's shortcuts because it ends up being the same thing every single time. And so we call these special right triangles. And if you can recognize what those special right triangles are, it's going to save you from having to do Pythagorean theorem. It's going to save you from having to do all this work. You're going to be able to jump straight to the answer. Okay, and the first thing we see here is what's called a 45-45-90 right triangle. And it's called a 45-45-90 because that is the sides, that is the measure of each of the angles in the right triangle. Okay, so we have 45 here, 45 here, and that means that this is my 90-degree right triangle. The angles are 45, 45, 90. Now, because the base angles are the same, here's another geometry concept. Because the base angles are the same, that means it's an isosceles triangle. That means two sides are the same. And if we look at it, we can see that because these two sides are both x. We have x and we have x. If we were going to do Pythagorean theorem, we would say that, I would say find your hypotenuse first. So let me get a different color here. So we find that right angle. We go straight across from the right angle. There's your hypotenuse. So that would be C. This would be A. And this would be B. And I could do x squared plus x squared equals, x times the square root of 2 squared. All that stuff would work out. All right, but here's the rule. If you notice, what is C? C is just the same value of A and B times the square root of 2. This will always happen in a 45-45-90. If I tell you that x is 10, if I tell you A is 10, guess what C is going to be? It's going to be 10 square root of 2. If I tell you that B is 5, guess what C is going to be? It's 5 square root of 2. If I tell you that A is 23, guess what C is? 23 square root of 2. So if you know what the side is, you automatically know what the hypotenuse is in a 45-45-90. You don't have to do a squared times b squared. A squared plus b squared equals c squared. You don't have to do Pythagorean's theorem. You can just go straight to the rules, like a shortcut, and find the answer. Okay? So, to find the measure of the hypotenuse, okay, we multiply the leg times the square root of 2. All right? We do that if we're trying to find the hypotenuse, if we're trying to find C. Now, if we know the hypotenuse and we're trying to find A and B, then we have to not multiply, but divide the hypotenuse by the square root of 2. Okay, that's what you have to know. So you have to always look at what do you have and what are you trying to find. And that's going to tell you whether you have to multiply or divide. If you know the leg and you're trying to find the hypotenuse, you have to multiply by the square root of 2. If you know the hypotenuse and you're trying to find the leg, you have to divide by the square root of 2. All right, here we go. I left up our rule, 45, 45, 90. We're going to use this to figure out the missing sides. All right, so don't give decimal answers. Leave it in terms of a radical. Here we go. Number 3. Well, first thing we got to figure out is what are we trying to find? Okay, so find the hypotenuse. That's always what I say first, is to find the hypotenuse because it will make your life so much easier. All right, so there's my right angle, which means C is my x is my hypotenuse. So x equals C. So that means, based on my rule, because I'm going from the leg to the hypotenuse, so if I go from A or B to C, I multiply. All right, so 8 times the square root of 2, and that's my answer. C is 8 square root of 2, x is equal to 8 square root of 2. Done and done. Easy peasy. All right, look at number 4. All right, think about what we have. Here's my right angle. So there's my hypotenuse. 10 square root of 2, that's C. So what am I trying to find? I'm trying to find A or B. So if let me change my color here so this makes a little bit more sense. If we know, losing my mouse. There it is. So if we know C and we're trying to find A or B, then we have to divide by square root of 2. Okay, so we take C, 10 square root of 2, and we divide it by the square root of 2. Now we have radical on the top, radical on the bottom. Look at what happens. They're going to cancel, and we're going to be left with straight 10. So these are going to cancel, and we'll be left with just 10. Let's look at number 5. All right, so what do we know? So there's our hypotenuse. So y is going to equal C. X is going to be like A or B. Okay, well, x is equal to A, which is equal to B. Remember, A and B are exactly the same. So if B is 7 square root of 2, guess what x is? 7 square root of 2. Done and done. All right, and that's because in a 45, 45, 90 triangle, 2 sides are always the same. So if they give you one of the legs, you automatically know the other leg. All right, next we got to find C, or y. Y is equal to our hypotenuse, which is C. So we just take that leg, which is 7 square root of 2, and we multiply it times the square root of 2. So now we have square root of 2 times the square root of 2. Remember, you just multiply what's underneath the radical. It's the same thing as 7 times the square root of 4. But what is the square root of 4? That's just 2. So it's 7 times 2, which is 14. All right, so y equals 14, x equals 7 square root 2. Okay, if you want to go ahead and pause the video here, try the next one on your own, and let's see the next one or two on your own and see how you did. Okay, I will say this is an earlier version. I made this PowerPoint before that we kind of modified your assignment, your lesson, so the numbers are going to be a little bit off. You don't have number 8 here, so we're just going to skip that when we get to it. But let's look at number 6. Let's see what you did. First thing you should do is look for what is the hypotenuse. Well, we find the right angle. We go straight across. That means y has to be C. It also means that x is a and 2 square root of 3 is b. Remember, a and b are always the same. X equals a, which equals b, so bam, we already know what x is. 2 square root of 3. Done and done. Okay, now let's try to find y. So we're going to take the side of b, because we're trying to find c. Remember, we're going to multiply by the square root of 2. So it's going to be 2 square root of 3 times the square root of 2. Multiply what's underneath your radicals. 3 times 2 is 6, and our answer is 2 square root 6. Done. Okay, don't think it's wrong because it looks weird. That's the answer. We just take whatever that side length is, we multiply it by the square root of 2, and we're done. All right, let's try number 7. All right, so this one's a little bit more difficult because here we find our right angle, we go straight across, there's C. All right, C is 6. In this case, we don't know what is A or B. All right, but think about our rule. All right, when you have the hypotenuse and you're trying to find the leg, you just divide by the square root of 2. Okay, now here's the thing. You probably, maybe, hopefully remember from either Algebra 2 or Algebra 1 that we never leave that radical in the denominator. We don't like radicals to be in the denominator. We can't divide by a radical. So how are we going to get rid of it? We're going to multiply both the top and the bottom by the square root of 2. So we'll get 6 square root of 2 on top, square root of 2 times the square root of 2, which is the square root of 4. So we get 6 square root of 2 on the top, square root of 4 on the bottom. What is the square root of 4? Just 2. That it? Almost. Look, we have a 6 on the top, we have a 2 on the bottom. Those numbers can simplify. We do not ever simplify the radical. Square root of 2, if it's underneath the radical, it's locked. You can't simplify it. Okay, we can simplify the 6 on the outside with the 2 on the bottom. 2 goes into 6 3 times, and our answer is 3 square root 2. Okay, does that make sense? I hope so. All right, we're going to skip number 8. I know your numbering is off. Your number 8's not this number 8, so I apologize for that. But let's go ahead and go to the next slide. We're going to skip all that. All right, here we go. 30, 60, 90. We have two special right triangles. 45, 45, 90 is one of them. 30, 60, 90 is the other one. All right, so if we look at this real quick, it's called a 30, 60, 90 because there's one angle that's 30 degrees, there's one angle that's 60 degrees, and there's one angle that's 90 degrees. Okay, one thing to remember is that from geometry, that in a triangle, the smallest side was always opposite the smallest angle. So what I would say is think about what is the smallest angle? It's 30 degrees. If you go across from that 30-degree angle, that's what we're going to call our short leg. All right, so if you notice in a 30, 60, 90 triangle, the two legs are not the same size like they were in the 45, 45, 90. So one's always going to be shorter and one's always going to be longer. Okay? The side that's opposite the 30-degree angle, that's your short leg. The side that's opposite the 60-degree angle, whoops, take that back. Obviously, the one that's opposite the hypotenuse or opposite the right angle, that's the hypotenuse. The one that's opposite the 60-degree angle, that's the long leg. So in a 30, 60, 90, we're going to have a short leg, we're going to have a long leg, and we're going to have a hypotenuse. Okay, now look at the ratios. Look at the side length. This is the rule that what we're going to go by. Everything in a 30, 60, 90 is based off of the small leg. The small leg is the key. So if we know what x is, the hypotenuse is always going to be 2 times x. And if we know what x is, the long leg is always going to be x times the square root of 3. What if I tell you x is 7? Well, the long leg has to be 7 square root 3, and the hypotenuse has to be 2 times 7, or 14. If I tell you x is 25, you know the long leg is 25 square root 3, and the hypotenuse is 2 times 25, or 50. Okay, the key is if you know the small leg and you're trying to find one of the other two sides, so if you're going from small leg to hypotenuse or small leg to long leg, you're going to have to multiply. But if you're going the opposite direction, so let's say that we know the hypotenuse and we want to then find the small leg, then we would have to divide. This is harder to write with the mouse than it looks. You're doing a great job, Mr. Weber. Oh, thank you so much. So kind of you to say. All right, so if we know the hypotenuse of the long leg and we need to find that short side, then we're going to just divide by whatever that factor is. So if it's the hypotenuse, we'll divide by 2. If it's the long leg, we'll divide by the square root 3. So it's even more important in a 30, 60, 90. What do you know and what are you trying to find? Those are the first two questions I always ask. All right, here we go. Let's try 9 and 10. Number 9. All right, what do we know? Well, we know the angle that's across from the 30-degree angle. We know the side that's across from the 30-degree angle. That means we know the short leg. Short leg is the key. So we apply the rules. The hypotenuse is going to equal 2 times 5. There's our hypotenuse right there. So x equals 10. The long leg, which is y, that's going to be our short leg, 5 times the square root of 3. So our answer is just 5 square root of 3. Question like number 9 is like the easiest type of question because they're giving you the short leg. Remember, the short leg is the key. Once you know that, you can quickly find everything else. Okay? All right. So, look at number 10. First question we ask, what do we know? All right, so we know that the angle across from the 30-degree angle is y. So there's our short leg. I'm going to abbreviate here, SL, for short leg, which means that the 6 square root of 3 here, that's our LL, that's our long leg, because C has to be our hypotenuse. So we know the long leg. Okay, so we have to find the short leg, because remember, the short leg is the key. So to go from long leg to short, we divide. What do we divide by? Whatever that factor is, which in this case is the square root of 3. So we're going to divide 6 square root of 3 by the square root of 3, and square root of 3 cancels, square root of 3 cancels, and y equals 6. Well, once we know that, remember that's the short leg. Short leg is the key, which makes the hypotenuse super easy to find. You take that 6, multiply it by 2, and that's 12. Remember, with these videos, at any point you can just pause, go back, listen to it again. If it really doesn't make sense, reach out to your teachers. They are going to be available to you throughout the day at different times. You can always send them a message on Edsby or Remind if they have set that up to get that question answered. But the sooner you get a question answered, the more successful you're going to be. All right, so here we go. 9 and 10. Why don't you try to pause the recording and try to do the next one on your own, and then we'll see how you did. Okay, I do know that number 12 is not on your page, so we are going to skip number 12, and we're just going to focus on number 11. What do we know? Well, we know the hypotenuse. So here's our right angle. We know the hypotenuse. All right, so y is across from the 60-degree angle. That has to be a long leg, which means x is the short leg. What are we going to find first? We're going to find that short leg because the short leg is the key. All right, and then we're going to apply the rules. So the hypotenuse is, remember, just 2 times x. So all we have to do is just divide this 18 by 2 to get to x. So the short side, x, is going to equal 18 divided by 2, which is 9. So x has to equal 9. Once we know that, short leg is the key. Our long leg will just be 9 times the square root of 3. Done and done. Okay? We're going to skip 12. Last thing we're going to talk about today. Right triangle trigonometry, SOHCAHTOA. Some of you are like, oh, I love this. And other of you are like, oh, do we have to do this? Here's what you have to know. Sine, cosine, and tangent just describe the relationship between the sides of two sides of a right triangle. Okay, so you probably remember sine is the opposite over the hypotenuse, cosine is the adjacent leg over the hypotenuse, tangent is the opposite leg over the adjacent leg. What's going to be important for you is to make sure you can find out what is opposite, what is the hypotenuse, and what is the adjacent. Okay, so what I always look at is the angle. Think about the angle. What is the angle that they gave us? Well, there's theta, there's our angle. Imagine you are standing with your back to this angle in this corner. All right, you're standing back here in this corner looking at the triangle. What side is opposite you? It's going to be B. That's your opposite side. Okay, the next thing I find is the hypotenuse. Where's the right angle? It's right there, which means C has to be the hypotenuse. Okay, so B's opposite, C's the hypotenuse. That leaves one side left. That has to be the adjacent side. The word adjacent means beside. And if you think about your perspective being in this corner, this side is literally beside you. So it is literally adjacent to you, which is why it's called the adjacent side. Okay? That's it. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent's opposite over adjacent. Those are the three things you have to know. So here we go. Man, I totally messed up this slide. All right, we'll fix that in a second. All right, so 13. First thing we have to do is find out what is the hypotenuse. So we have a side that's missing. Where's our hypotenuse? It's right there. That's the missing side. We have to find C. So we go to Pythagorean's theorem. A squared plus B squared equals C squared. Plug in for A and B. 12 squared plus 9 squared equals C squared. 144 plus 81 equals C squared. C squared equals 225. All right, that's not C, that's C squared. So what do? Square root, and C equals 15. All right, so once we have that, now we can do our ratios. Sine is opposite over adjacent, but let's think about where we are. Opposite from where we are, that's 12. Hypotenuse, that's 15, which means 9 has to be adjacent. All right, so once we have the opposite and the adjacent and the hypotenuse, we can jump into solving this. Sine is opposite over adjacent. That would be 12 over 15, which equals 4 over 5. You always have to simplify this down. Always, 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 always. All right, let's look at cosine. Cosine's adjacent over hypotenuse. That would be 9 over 15, which is 3 over 5 once we simplify that down. Last thing we're going to do is tangent, which is opposite over adjacent. That's 12 over 9. And then we simplify that to 4 over 3. Make sense? Okay, just for a second, don't look at the answers to 14. I do apologize. I got my animations all messed up here. First thing we're going to do is we're going to ask ourselves, Pythagorean's theorem, a squared plus b squared equals c squared. Okay, so we can see that the hypotenuse is 20 and the side that we know is 10. Wait a minute, that should trigger something to you. We could do this. We could do Pythagorean's theorem, 10 squared plus b squared equals 20 squared, just like we did on this previous example on number 13. But if we notice that the small leg is half of the hypotenuse, wait. This is a special right triangle. This is a 30, 60, 90 right triangle. And if we know that, then we know the short leg is 10, the hypotenuse is 20, and the long leg has to be 10 times the square root of 3. Okay, so this is why we learn special right triangle rules, is they save us this time. I don't have to do all that algebra with Pythagorean theorem. If I recognize that it's a special right triangle and it fits the rules, then I know that the long leg is going to be 10 square root of 3, done and done. Okay, so now we just have to apply our rule. So let's focus on the sign. Sine is opposite over hypotenuse. So we have 10 square root of 3. So x is our opposite side. Let me get my mouse here. So here's our opposite side, 10 square root of 3. The hypotenuse is opposite the right angle. So it's 20. So this is going to be opposite over hypotenuse. So 10 square root of 3 over 20. This is going to cancel. 10 goes into 22 times. Remember, the 1 is invisible. We don't have to write it. So it's just square root of 3 over 2, done and done. All right, look at cosine. Cosine is adjacent over hypotenuse. So from the perspective of x, 10 is our adjacent side. So it's 10 over 20. Simplify that down. 1/2. Cosine of x would be 1 over 2. Lastly, tangent. Tangent's opposite over adjacent. Opposite is 10 square root of 3. Adjacent is 10. So 10 square root of 3 over 10. These two things are going to cancel, and we're left with just plain old square root of 3. Okay? And whew, that is it. That was a lot. All right, so let's go back and make sure that we understand what the main concepts were from today. I forgot to say this at the top, but this is from pages 355 to 362 in your textbook. So if you do have questions, you can go there to look for it as well. All right, so here we go. First thing we talked about was reviewing Pythagorean theorem. A squared plus b squared equals c squared. A and b were the legs of a right triangle. C is the hypotenuse. Okay? Now, the next thing we talked about was special right triangles. 45, 45, 90 right triangles. If you know the side length x, you know the hypotenuse has to be x times the square root of 2. Second thing we talked about was our 30, 60, 90 right triangle. All right, so with 30, 60, 90 right triangle, the legs are different sides. If you know that small leg, the one opposite the smallest angle, the 30-degree angle, that's your small leg. That's the key. Everything is based off of x. The hypotenuse is 2 times x, and the long leg is x square root of 3. The last thing we talked about was reviewing the trig ratios, SOHCAHTOA. All right, so you have to understand that from whatever angle you're looking at, in this case we're looking at theta, you can find the opposite side, that's B. The hypotenuse is always opposite the right angle, so that's C. And the one that's beside it is the adjacent side. Okay, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, hope that all made sense. Look at your lesson, your assignment, see if you can go through those problems. If you have questions, please, please, please reach out to your teachers. We are here to help you any way that we can. All right, good luck.